Welcome everyone. It's the seventh meetup of Romania Power BI and Modern Excel user group, and we have the pleasure to have Brian Grant as a main guest today. Thank you, Brian, for accepting the invitation, and let's go through some quick slides at the beginning, and then we can start with your session because we have a really big announcement to make today. We are the first user group in the world to have something. This is why I really wanted to go through the slides. So the meeting agenda, it's not very complicated. It's the starting part, the overview. I'd like to present to you also the next meetups. As most of you know, this is a monthly meeting. I'd like to announce a really cool partnership that we are starting this month. And then we'll have a live Q&A session in the end for Brian. And then a surprise, a raffle, and the wrap up. So just before we start, please make sure the microphones are muting during the session. So as less noise as possible, it's coming through the call. If you have questions, please type them in the chat with the Q in front of them so we can spot them easier. If you or me are having problems with the internet connection, please drop off and join again, because the meeting is recorded and we can see what we've missed during the recording. As next meetups, the next one will be on September 30th with Dr. Liam Bastic. It will be an introduction to dynamic arrays, and I couldn't recommend you more to join this session because dynamic arrays are awesome, and Liam, it's really a great presenter. So I'm waiting for all of you in September. Then in October, we have as a guest Alberto Ferrari, who's gonna do an introducing direct query for Power BI datasets and analysis services. And then in November, we have the founder of Zebra BI Visuals, Andrei Lapagne, which will do an overview and some very specific details on the Zebra BI Visuals. It will be great, that one too. So I wanted to announce a very big step for our user group. We are starting a great partnership. Great, I mean, great for us, the learners, and probably for Enterprise DNA. We will start a very valuable partnership with Enterprise DNA starting this month. As many of you, probably most of you know, eDNA has an incredible learning resources on the portal. Brian Julius, who is here with us, made this happen. So thank you, Brian. Maybe you can say a few words if you'd like.
Sure,
but in summary, eDNA became the primary official sponsor of Romania Power BI user group, and I will let Brian to announce what are we getting sponsored with.
Thanks, Christian. Really appreciate the opportunity to talk briefly and be with you here today. And I look at Enterprise DNA and I look at what you're doing, and I think there are three things that come to mind. Is that we are passionate about and obsessed with Power BI, maybe some of us to an unhealthy degree. We're focused on providing opportunities for users to learn, to improve their skills, their organizations, and their career opportunities. And we're committed to creating a friendly, positive, and inclusive environment where everybody feels welcomed and can connect with other users to quickly solve their problems, to exchange information, to develop relationships. And when I think about that we're trying to do, that reminds me and echoes exactly with what you all are trying to do within your group. And I think our objectives and our goals are so closely aligned that when I was talking to Sam Mackay, our CEO, we really wanted to do something to reach out to all the user groups and promote what you're doing to use our platform and our worldwide membership to help you grow your communities, and also to provide you exposure to what we think are great resources that we can provide. And so what we're going to be doing each month is providing at no cost 3 full annual Enterprise DNA memberships, as well as 3 annual subscriptions to our Analyst Hub tool that will really help kind of speed your Power BI development. And we're doing that just as a way to, give you a chance to incentivize and promote your events, kind of maybe draw some additional people. And, do I hope that through exposure to Enterprise DNA that more of you will become members and get involved in our community? Sure, I do. But what I really hope is that we have a lot of free and open initiatives. I think we run the premier data challenge for Power BI out there, and we'd love to see more of you. I recognize some names just popping up in the chat of folks that I know from the challenges and from our community, and we'd love to see all of you participate in that. As I say, it's free, it's open. It's a great opportunity to learn, to grow, to develop relationships. Even our CEO provides a detailed written feedback on every entry received, and that in itself is a great learning opportunity. So I just wanted to say thanks for the opportunity to be involved with you all. I want to especially thank Christian for his leadership and friendship, and we look forward to a long and fruitful partnership with Romania Power BI and Modern Excel User Group.
Thank you, Brian. It's really an honor for us to be the first user group in the world being sponsored by eDNA, and I'm really looking forward to continue this partnership as long as possible. And as we spoke earlier, I was thinking how to distribute these free memberships, and there are some ideas on the internet, and one of them was to have a live raffle, and this will be this is what I did at the end of this meetup, with a form, 2 flows, 1 Power App and 1 Power BI, so we can have everything better together. So for everybody in the meeting today, please scan this QR code, fill the form, put your option whether you want to be in the raffle or not, because maybe you already have a membership and you don't want to be in that raffle. And I'll show you in the end. We'll run the raffle, and I'll explain you briefly how I did it with 2 flows and 1 Power App and 1 Power BI report. I will also put this link in the chat if you couldn't scan it or get the short link. And so let's get started with the session today. As I started, I have the big pleasure to meet and directly talk finally with Brian, who is a senior BI consultant at CSG Pro. He has a very interesting background. He'll probably speak a little bit about it, but this is probably the reason why he's explaining the technical stuff so well. I'm following him on the blog, on the CSG Pro blog, and I saw some other sessions with Brian, but what I love most is the elements of DAX playlist that he has on YouTube. I think that for everybody who is here in the call, this is a must go through playlist. I think it's 50 something videos, right, Brian? and
that
growing.
sounds about right. Yeah.
So with no further ado, thanks again, Brian, for accepting our invitation, and the stage is yours.
Thanks, Christian. I appreciate that. I'm so excited to be here. Oh, so is Ramona. Hold on, my dog just showed up. I'm gonna see if I can't corral her out of the room for a second. Yeah, I know, no hat. The new chair doesn't allow it, which is kind of a bummer. So anyways, here, let me close my office door so that way the dogs don't constantly come in and out. Give me about 2 seconds. Timing. As I was saying, thanks again for hosting me. I'm super excited about this. I think this has quickly become my favorite presentation to give, and every time I do it, I just enjoy it more and more. So I'm really hoping you guys enjoy it as much as I do. So speaking of which, my name is Brian Grant. I work with CSG Pro out here in Portland, Oregon. Don't ask what CSG Pro stands for. Nobody remembers. So we do all things Power BI. I do data visualization. I do ETL stuff with Power Query. But my biggest love, I think, these days is DAX, because it's just such an interesting problem to try and solve. And the beautiful thing about DAX is if it's presented in the right way, it's actually not nearly as difficult as you might imagine. I don't want to say it's easy, but in the same way that like playing chess can be somewhat difficult, but the basic concepts are easy, DAX the same way. Getting really, really good at it is difficult, but the basic concepts are not that tricky. So I'm going to go ahead and share my screen. I should get a filter that puts the hat on me is what I should do. And can somebody give a thumbs up or something when they can see the screen, just so I know that that's all working okay. Oops.
It's okay. It's okay. Both the screen and the missing head.
Okay, and everything just collapsed. Give me a second. My AV fell apart.
I know, it's black now.
Okay, give me a second. Let's see if I can get this thing to work. Yeah. Okay, so yeah, sometimes it has trouble with this. Let's try this again. Okay. Can you see the screen okay?
Yes.
Okay, let's see if I can do this and chat at the same time. And all right, so everything's working good. What's a presentation without some AV hiccups? All right, so enough about me. Let's talk about DAX, right? So we're going to be talking about DAX, which is Power BI's advanced calculation language. And as a preview, basically the only thing I'm going to tell you throughout this next, 70 minutes or whatever, is it's all tables. Not even mostly tables. Forget what I say down here. It's not mostly tables. It's all tables. All right, so with that little preview in place, why don't we just start with a nice, simple definition for what DAX is, right? So I find that a lot of folks, even if you've been using DAX for a while, it's hard for people to put their finger on what is it? What am I supposed to do with it? Why does this exist? Why are there two languages? Why is there an M language and a DAX language? Well, let's start with this. What is DAX? DAX is a querying language that builds summary tables on demand. What do I mean by summary tables? Well, so imagine this, right? We're going to load data into our data model, technical term for it, but we're going to go get a bunch of data. Maybe we get 13 million sales transaction rows. We get a big table with all of our products, maybe a couple thousand rows there. We get a table with all of our stores, a couple hundred rows there. We get all this really detailed information. But the detailed information by itself isn't helpful to decision makers. We have to summarize it. So what we're going to do is we're going to take this highly detailed information, right? And the DAX engine is going to be in charge of creating summaries of it. A summary like this, right? This over here is a summary table summarizing this physical data over here, right? So while this is not going to help decision makers in any meaningful way, something like this might. Hey, we could see total sales broken down by our different cities and our different categories, right? So DAX is in charge of summarizing that data very, very quickly. Now, how quick is quick when I'm saying this? Well, watch this. When I come down here to my different tiers, let's say that I want to see my sales for just my premium products. I click on premium, and boom, just like that, before I can even get to the next sentence, DAX has re-summarized that data to produce a new summary table to get drawn as this visual right here. So every single time you interact with Power BI by slicing or cross-filtering or adding filters in your filter pane, Power BI is going to re-summarize that data and do so incredibly quickly, even if you've got millions and millions of rows worth of data. So that's what Power BI does, or that's what DAX is. How does it fit into Power BI? Well, right, we look at this little pipeline here, right? So DAX is in charge of summarizing data, but for the data to get summarized, you have to have it, right? That helps. So the job of getting data to summarize is done by the M engine, also known as Power Query, or sometimes Get Data, however you want to call it. This M engine is in charge of reaching out to source systems, like maybe a SQL database, maybe an Excel file, maybe an Access database, somewhere where the data lives on a day-to-day basis, grabbing it, pulling it, cleaning it up, and then loading it into the data model, right? So all these detailed tables are getting pulled from their sources via the M engine. And the thing about the M engine is it's a lot easier to, frankly, work with, but it's really, really slow. Now, the fact that it's slow comparatively is okay, because this is going to run usually about once a night at about 2 in the morning. So the fact that loading this data takes 45 minutes is no big deal, because everybody's asleep, right? Now, once you've got this data loaded, when you need to summarize it, those summaries can't take 45 minutes, right? Which is why they invented a whole new language, DAX, to create those very, very quick summaries, right? So DAX is going to be in charge of creating the summary tables based off of the data model, right? Well, then why are we doing that? Well, because we want to draw those summaries as visuals. That's done by the Power BI rendering engine, right? So every time I sort of click and interact, right, with my slashers over here, right, DAX is re-summarizing the data, right? The data doesn't need to get reloaded, because that happens at 2 in the morning. But DAX has to re-summarize the data based on my different slasher selections down here, right? And when it re-summarizes it, then Power BI can take those summaries and draw them as any number of visuals. Okay, so pop over here for a second. Some folks might be thinking at this moment, this sounds a lot like pivot tables. And the concept is actually similar. DAX is better, but the same idea kind of is true, right? It does the same sort of thing. With a pivot table in Excel, you load a lot of data, right? A lot of data into a range in Excel, and then you create a pivot table where you've got some pivot table controls where you drag different columns into columns, rows, and values of your pivot table. And then the pivot engine can create summaries on the fly. And if you want to move stuff from columns to rows or add slashers, you could do that. And every time you interact with it, it re-summarizes this detailed data. So DAX is going to do the exact same kind of thing. The advantage, though, is it can work with much bigger tables of data, and it can work with multiple tables of data. Also, you can do far more advanced calculations with DAX. That's sort of how it works. Okay, so let's talk for a minute more about summary tables. Okay. So every time you have a visual in Power BI, that visual is a rendering of, a drawing of a summary table produced by the DAX engine. So if we imagine that we've got these 1, 2, 3, 4 visuals over here, right, where we've got this line chart, this stacked column chart, these 2 cards over here, each one of these visuals is a rendering of a summary table that might look something like this, right, and this, and this, and this. So in order to draw this line chart here, where we've got sales broken down by year and quarter, well, we're going to need a summary table from DAX that has total sales broken down by year and quarter. DAX produces a table that looks like this. Power BI then takes it and draws it as a line chart, or it could draw it as something else if you want to draw it as something else, right? Down here where we've got this column chart, where we've got sales broken down by category and cities. Cities are the different things on the axis, and category are the different sort of segments of the column. Well, in order to draw this visual, DAX is going to have to produce a summary table that looks like this, with total sales broken down by category and city. DAX produces this summary table here, right, which then gets drawn as a visual over here. It can be drawn as this column chart. It can also be drawn as something else. And that's even true with these cards. In order to draw this card that says total sales is $64 million, you need to have a summary table that says what the total sales is. By the way, I do apologize for everything being in North American US dollars. I found, though, that when I travel around, people seem to be more okay with it than I would assume. So in a perfect world, I would have converted it to local currency. Because of the later part of this presentation, I think you will see why that wouldn't work very well. So anyways.
It's okay. It's okay.
Yeah. Okay, cool. So now I want to point out that every time you interact with a chart, like by clicking on, say, 2017 here, right, these visuals change, which is what an end user expects. the reason that they are able to change is because DAX can re-summarize the data based on the slicer selection to create this summary table and this summary table, this summary table, this summary table. And it does it lightning fast, right? And so when it re-summarizes it, Power BI can then redraw it with the new summarized data based on what the user has selected, looking at the subset of the data that they want, right? Now, what I want to point out at this point, some astute people in the audience may be noticing. Here, let me clear these slicers here, right? This is actually a summary visual. So if I click on this tile and I come over here to the visualizations pane, right? This is actually just a table visual. It's not strictly speaking a summary table, but the table visual is a very, very good representation of what the summary table looks like, because it basically takes the summary table and then just draws it with some fonts and whatnot, right? So for folks that were concerned, I can show you how you could see the summary tables if you want to, but this is just a very good, quick representation of them. Okay, let's talk for yet another second on these summary tables. Okay. If it wasn't immediately obvious, if you've got a visual, every single shape in that visual, glyph is the technical term for it, right? Every single shape is going to be drawn from one row in the summary table. So like down here where I've got sales for food in Washington State, well, that's going to come from this summary table on the row where we have food in Washington State. So that 5 million, that's how it knows to draw that column exactly that high right there. And if I come here to the first little glyph, the first little column, where we've got beverage sales in Oregon and it's $33 million, well, that comes from this row right here where we've got total sales for beverages in Oregon, right? So every single shape in a chart corresponds to a row in a summary table. That's true for column charts, and it's also true for line charts as well, right? So if I look at any point on this line chart, like walk-up sales in 2018, well, if I look at that, that's about 10 million. Well, that corresponds to this, that 10 million right there, walk-up sales in 2018. That's how Power BI is taking these summary tables and drawing them as visuals, which are a little easier for decision makers to look at. Okay, so we pause for questions here real quick. I tend to talk kind of fast, so it can be hard to squeeze questions in. Any questions so far? You can drop
nothing in the chat.
Okay, fabulous, fabulous, fabulous. Okay, so let's pop over and we're going to look at summary queries. So you may be asking yourself, well, wait, I get that in order to draw a visual, I need a summary table. I even understand that DAX is in charge of drawing these summary tables, but how does it know what to get? How does it know what kind of summary table to create? Well, that is the job of summary queries, right? So if we imagine in Power BI, here, let me twirl this. Well, I'll even leave it open right here. So imagine that we create a visual that looks like this in Power BI down here, right? When we create this visual, we're going to go to the visualizations pane and say, I want to create a clustered column chart. And then we're going to drag state into the axis, which is why you've got the two states there. We're going to drag category into the legend, which is why you've got the clusters for beverage and food there. And we're going to drag the total sales measure into the value section, which is why these heights represent total sales. Okay, so even if you've never heard of DAX, all of this makes a certain amount of intuitive sense. But how do we get from here down to here, right? So when we create the visual by dragging and dropping stuff here in the visualization pane, Power BI is smart enough to know, okay, in order to draw this as a visual, I'm going to need to have a summary table with total sales broken down by category and state. That's the only way that I'm going to be able to draw it, okay? So what does it do? It writes a summary query in the DAX language. It says in order to draw this, I'm going to need to have a summary table that looks like this. Well, how do I get a summary table that looks like this? I'm going to write a summary query that looks like this. Now, you don't have to learn all this, but you can at least sort of glance at it and get a sense of it's not that difficult, right? It's not that complex. So what does a summary query look like? It says, oh, I'm going to summarize columns. Go get all the combinations of state and category. And then we're going to add a calculation column that says, go get a column called total sales. And to do it, we want to run the total sales measure for each and every row. And so DAX says, okay, it gets this and says, I know how to do that. And it creates a combination, every combination of state and category right there. And then it adds a column called total sales right there. And to get the numbers, it runs this measure for every single row right there, 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 and there. Okay. So Power BI writes this summary query, it sends it over to the DAX engine. DAX gets it and says, I know exactly what to do with this. It spins up a summary table that looks like this, sends that back to Power BI. Power BI grabs that summary table and sends it to the Power BI rendering engine, which can draw it as a visual that looks like this. Okay. All right. So at a high level, that's how it works. What's interesting is every time I interact with the report, the visuals change, which is good. That's what an end user expects. But what happens mechanically, right? So let's imagine that I just want to look at 2017 sales. So when I click on this slicer for 2017, what you will find is that Power BI is going to detect that and rewrite the summary query to include a filter for 2017. And it looks something like this. I click on 2017, boom, it adds a line right there. Fiscal calendar year equals 2017, right? If I click on 2018, you probably have a guess. Now it says 2018. If I click on 2016, it says 2016, right? So it's just that same simple single function, right? Summarize columns, go get all the column or combinations of state and category with the filter for year equals 2016 and add this column to it using that measure, right? So Power BI rewrites that query, sends it off to the DAX engine. DAX resummarizes it with these smaller numbers corresponding to just the 2016 sales, sends it to Power BI, and it draws it as these kind of smaller columns. Same thing happens when I click on state. So I click on Oregon right here, right? I click on that, and now it's going to add yet another row to my summary query to say, oh, the user wants another filter, this time a filter for Oregon. Or maybe I click on Washington, and now it's got a filter for Washington, right? So then Power BI rewrites this summary query with these new filters that the end user wants, sends it off to the DAX engine. The DAX engine resummarizes it. Notice we've got fewer rows right now because we're just looking at Washington. And then it sends that to Power BI, and the Power BI rendering engine is going to draw it as these teeny tiny columns right here. Okay. Now this even works. I will have to show you the data model in just a second. This even works when you do cross filtering, right? So let's say that I want to look at just my walk-up location stores, where you walk up to the restaurant to get your food, right? If I click on that, boom, it gets even smaller. Well, the fact that it gets smaller is what the end user expects. Why does it get smaller? Well, that's because it adds yet another line for layout equals walk-up. So every time I add slicer filters or filters from cross-filtering or even filters here from the filters pane, it's just going to keep adding lines to the summary query corresponding to those filters that we want to add, right? Power BI adds them, sends them off to DAX. DAX resummarizes it, sends it back to Power BI, and Power BI draws it over and over and over again. Very, very fast. Very, very fast. Okay, so I was going to pause here for questions, and there are some questions. So let's see.
Yes.
So yeah. What do we got? Let's see.
One of the questions is, can we see the measures that you are using in this demo file or the data model?
Sure, yeah. So let me start with the data model. And I hope doesn't have too much complicated stuff in it. Oh, and it's not beautiful. Here, I'm going to reorganize this a little bit the way I like to see these things. So I should do a blog post on this. I'm going to put my facts down there. There. I'll put my dimensions there. And there. And why does sales have that relationship? Probably because it shouldn't even be there. And whatever. So the data model, other than one little bug that the auto detect seemed to create, is pretty simple. We've got a stores table. We have a products table. We've got, oh, that's why. This is a dimension table. I teach this stuff. You think I'd be better at this? Okay, so we've got 3 dimension tables: stores, products, and the fiscal calendar. And we have 2 fact tables, a sales table and an active customers table that we actually, I don't even use it unless somebody has a specific question around it, right? So basically, we've got the sales table. That's where the transactions are, a stores dimension, a products dimension, and a fiscal calendar, and a whole bunch of measures. Now, let me show you the simple measure that you may be asking about. The simple measure is total sales, and we're gonna. If you're like, Brian, what's the measure? We'll get to that in a second. But if you studied ahead of time, we could go look at the total sales measure, which is quite simple, right? It uses this SumX function, which we'll get to in a little bit, where we say go get all the visible rows of sales as what we're going to call a temp table, right? Go get a temp table with all the rows of sales that are currently visible, and by currently visible, I mean based on whatever slicer user selected. For every single row, multiply the units times the price, and then sum up the result, right? And that's as simple as it works. Now, Brian, how did you get this thing? Well, that is quite a bit more complicated. In fact, I think it's hidden, right? Brian, do you have some secret thing to do this? No, just a lot of DAX. So
it's probably a long one.
Yeah, this is going to be a little bit longer. So there's a whole bunch of stuff in here to get that sucker working. No magic there other than a lot of DAX. But I'm happy to share it with people if people really want to see it. So basically, it just goes and draws us as a bunch of text. It's kind of fun. Were there other questions out there? Other questions?
Yes, there is one from Jessica. When I use selected value in a title to make the title dynamic, is that not respond to X filtering? Could that be related in any way to what you showed about how underlying DAX for the visual is written?
It could be. I will say I simplify a little bit here. So because I don't want to make things too complicated, if we were to take a time machine back about 6 years at this point, the behavior would be identical to what I'm showing on this slide, where filtering via a slicer and filtering via cross-filtering does the exact same thing in the code. In reality, they've introduced some new functionality, basically to speed things up. The concept is the same, but there are some subtle differences between the two. Because of those subtle differences, you might find slight differences in behavior between slicing and cross-filtering. Now, you'll still get a line in there that says something like layout equals walkup, but it'll have a function wrap around it that changes some of the way that the thing evaluates. So that could be why, right? Short answer is it could get a little bit complicated. But if you can understand the simple version of it, I think that's the key takeaway from this slide. Any other questions out there? Yes, happy to help.
No, for now, no? Yeah. How is this query changes at user request from Ashish?
What's that?
So when you were changing the slicers, probably yes. This is when he asked, how is this query changes at user request? So
that's Power BI is in charge of that, right? So the Power BI tool, right? Here we're looking at Power BI desktop. It is in charge of detecting selections on slicers and cross filtering. So whenever let's clear everything. So let's say a user comes in and I click on 2017, Power BI detects that click and says, oh, in order to redraw this visual, I need to resend out a summary query. So Power BI, the listeners hear this, right? They say, okay, what are the new slicers? Let's say that the user selected two things. Okay, so the new slicers include this and this. Power BI then, because it hears it, it knows I need new summary tables. It rewrites the summary queries with those filters in place, sends it off to DAX, and DAX can then resummarize. So Power BI is in charge of it. Let me know if that answers your question or if you have a follow-up. Let's see. Anything else out there?
No.
Pretty good. Okay, fabulous. Okay. So the one thing that's a bit mysterious at this point, let me simplify this a little bit, is here we have total sales by category and state. And if I look at this function, I don't quite know what summarized columns is, but yeah, I kind of get it. We get all the combinations of state and category, and then we add this column to it. What's this thing in square brackets? How come there's no actual formula in here, just this name, right? Well, that's where we get into measures. And the idea is that a measure is going to allow us to pre-write our formulas. That way, in our summary queries, we don't have to have the whole big formula written out. We can just have a reference to this preset formula, okay? Let's pop over here to measures, right? So the idea is if we might have multiple visuals that have the same business question associated with them, right? So in this visual, we're breaking down total sales by our store layout and our store state, right? And in this visual, we're breaking down total sales by our fiscal year, right? Well, the fundamental underlying question, what is total sales, is the same both in this visual and in this visual. We're grouping it in different ways, but the question is the same. So in Excel, you have to work very hard to make sure on page 1 where this exists, the calculation for total sales is the same as this over here on page 2, right? So in Excel, you'll often go between worksheets and the formulas are completely different. So Power BI says in the DAX engine, we're going to have people predefine our formulas and create a measure. Measure might look something like this. So if we know that we're going to need total sales in this visual, and maybe several other visuals, we will create a measure with a preset formula. The formula is fairly simple. It's SumX sales. Go get all the visible rows of sales. for every single visible row, multiply the units times the price, right? The quantity times price, and then sum up the results. And that's how it works. It works that way in this cell and in this cell, right? And the good news about this, well, there's a couple pieces of good news. One is if you have a 100-page long report, you know that total sales is always being calculated the same way because that's what a measure does. Furthermore, if you need to fix the measure because the formula is broken, it's not like Excel where you have to go page by page, cell by cell. It takes forever and you make a bunch of mistakes. With DAX, you just go find the measure that's broken, change the code, and then when you hit enter, immediately all 100 pages are fixed, now using the right formula. If there are other measures that reference that measure, those two are also fixed, right? Very, very powerful, okay? Now, when people say that they are learning DAX, most of the time what they really mean is they're learning to write measures. There is more to DAX than measures, but in a practical sense, as a person creating reports in Power BI, creating measures, defining them, writing down these formulas is most of what you do, okay? All right, so any questions out there?
There was an additional one from Jessica.
Yes, let's see. So if we can see the
Could
changes.
we see the? Yeah.
Yeah, so if you want to see the real summary query, which is a bit more complicated than the version I'm showing, but the guts are all still there, the essentials are all still there, you can indeed go to the performance analyzer, right? And in the performance analyzer, I'm going to go start recording. And when you hit the start recording button, what you will notice is every single visual has this extra button that wasn't there before. It looks like that right there. So what this will allow you to do is refresh just that tile, so you don't refresh all 9 things on the page. So if I refresh this tile, right, you will see this right here. It took a fifth of a second to do it, pretty fast. When you twirl it open, though, you hit this copy query button, and if you copy the query, you can go to my very favorite development environment, Notepad. I have Notepad++, and I still mostly use Notepad. And you can see the summary query. Now, it's a bit more complicated, but the essential part, the part I was showing you with the summarized columns, is right there, right? Same exact thing. Here, I'll even format it a little bit nicer for you so you can see it. And if you were to add slicers, sure enough, you would see those changes reflected in here. Because they want it to run nice and fast, they have added some functionality that is a little less simple than I had it. Again, if you were to hop in a time machine and go back 6 years, you would see the simple version I was just describing. The new version works the same way. It's just slightly more complicated. And to me, I think it's more important to understand the simplicity before you move on to the tricky concepts. But to answer your question in a very long way, yes, you can see the summary queries that are generated. The DAX queries, another way of saying that. Other questions out there?
No, nothing for now.
Fabulous, fabulous. Okay, I'm going to remember to stop this. There we go. Okay. So, hey, that's cool. I understand this idea of a pre-built reusable formula called a measure, right? And why are you going to need it? Well, if you want to do anything other than simple sums and averages, which is most people, you're going to need to write DAX. DAX is going to let you do things like calculating simple ratios, maybe a margin percentage, maybe a shipping cost percentage, goal to actual variances, just differences and also percentages, year, quarter, month-to-date sales, rolling 52-week stub, year-over-year sales, returning customers, new customers, lost customers, dynamic sales ranking, what-if scenario analysis. Anything more complicated than a simple sum or an average, you're going to need to have DAX for, right? So that's nice, Brian. I'm really glad about that. But how? How do you learn this language, right? So the good news about DAX is it's simple once you understand it, which is a very nice sentence, but this once you understand it part is very, very tricky, right? So in DAX, there's only 3 main types of operations, and they interact in very predictable ways. So you need to be able to imagine what's happening in DAX to write it effectively, but you can't see it, right? What you can see is the inputs and the outputs. So I could go look at a physical table, like I could come over here and say, hey, where's the sales table? Oh, there we go. There's all 13 million rows of the sales table, right? I could see my measure definition. That's right over here, right? That's right there. Total sales somewhere in here, right? I can even go look at the summary query, which I showed you a second ago. I can see all that stuff, and I can even see the output. What I can't see is the stuff in the middle, So, and that's the part that you actually need to understand. So what happens in between our loaded physical tables and our measures and these summary tables? How do I get from here over to here, right? Is it magic? Well, no, it's not magic. It's not magic, right? What it is, right? What it is more tables, right? So how do we get from having a physical table? This is in this example, we have a very small physical table with a summary query and a measure definition. How do we get from here over to here? The answer is a bunch of tables in the middle. So in DAX, you start with tables, physical tables that you load, the detail tables. You end up with the summary table, which is a summarization of this physical table. And to get from the physical table to the summarized table, there's a whole bunch of tables in the middle, right? We call these temp tables, right? One way you could describe the art of writing DAX is the strategic procurement, manipulation, and application of these temp tables, right? So if you learn how to work with these temp tables, you know DAX, okay? Now, the other piece of good news is that in order to manipulate these temp tables, there's only 3 kinds of operations you need to know about. Derivations are my fancy name for the thing that create these temp tables. Iterators is my fancy name for the things that process the temp tables by summing up values or averaging values. And revisor is my fancy name for taking a temp table and adding it as a filter, right? So there's only those 3 things. Now, at this point, you might be asking yourself, I have not heard these fancy names that you're talking about before. What in the world are you talking about? Where do these come from? Well, this has to do with my Elements of DAX video series and I guess framework that was mentioned earlier. The idea with Elements of DAX is this is a mental framework, which is a fancy way of saying a bunch of terms and ideas that are designed to help you understand DAX, to see what's happening underneath the hood, right? So it sort of sits on top of the DAX language. You won't see these terms in any official documentation from Microsoft, and that's okay. They're not official. They're sort of things that we've added on top of it to help you understand it. And they're going to do things like categorize functions into sort of buckets to help you see patterns in the language. It's going to rename some of the terms with, I think, easier concepts, even if they're a little bit less accurate. And it's going to hide some really advanced concepts that, frankly, you don't need to know if you're just trying to get your head wrapped around how DAX works. So if you are hearing terms that you haven't heard before, that's why, because I've made them up. Hopefully, by making them up, I make your journey easier, not harder. That's sort of for you guys to judge. Okay, so Elements of DAX, what do we mean by that? Well, basically, as I said before, DAX is all about working with temp tables. And when you work with temp tables, there's 3 kinds of things that you're going to do. You're going to create temp tables, right? I call that a derivation because the table is derived from the physical table. It's based on it. You can process a temp table by adding this, what I call an expression column, where I just run a formula for each row. And I either sum up the results, I average them, or maybe I keep all the true rows and create a new temp table. Or maybe what I want to do is take a temp table and add it as a filter. We call that a revisor. These are the 3 things you do in DAX. You do them over and over and over again. And if you understand these guys, your ability to write very complex DAX will jump, will skyrocket, hopefully to make things a whole lot easier for you. Okay, and yes, we will be adding a link to it at the very end. That's the part I always kind of forget, but I'm going to be good this time and remember it. Okay, so I could take these simple ideas here, and I could redraw them as a more complex chart where I've got the same 3 elements, revisors, derivations, and iterators, the things that get temp tables, the things that aggregate them, process them, and the things that add them as filters. And I could even show all the relationships in here. You don't need to memorize this. Hopefully, if you take my whole course, you'll be able to look at this and sort of piece together and say, yeah, I kind of get how all these things works. What I want you to take away from this slide, though, is there's not that much here, right? So this is the majority of the hard part of the language is here captured on this slide, where we have 1, 2, 3 things and 1, 2, 3, 4, 5 different relationships. So that's like what, less than 10 things that you have to learn. Now, those 10 things are tricky, but it's still like less than 10. You can learn this. You can understand how this works. You might think that DAX is this big spider web of concepts and ideas, and it's not. It's actually very, very small. Again, chess is a really good metaphor. The number of rules is quite small. Getting really good at them is still tricky, but the actual basic rules are fairly simple. Okay, so Brian, that's great. This has gotten very, very heady. It'd be really nice if you could make this a bit more concrete for me. Well, you're in luck. That's what I'm going to do. So what I'm going to do is I'm going to close or minimize minimize this window right here. I've got another PBX file that we're going to look at very quickly, assuming I can successfully drag it over. Hey, there we go. Okay, so, well, actually, you know what? I forgot to pause and ask for questions. Are there any questions about what we talked about so far? Now that I just blew through the part where you would normally ask them. Any questions on the stuff that we sort of covered a minute ago? Or is it like, I think I have a question, but I'm pretty sure you're going to answer it in the next section, or maybe you will. Okay, I don't hear people jumping out.
No.
Full steam ahead. Fabulous. Okay, so here we have the simple.pbix. Why do I call it simple.pbix? Because here's the data model we're working with, right? It's one table, and it's got 7 rows in it. So here we have transactions for a restaurant, right? In this restaurant, which is probably going to go out of business soon because we only sold 7 things, or 7 transactions. For every single row, we have what shift it happened in. Was it lunch or was it dinner? Was it to go or was it dine in? What did somebody buy? Did they buy pasta, a burger, or a salad? We have the number of units that they bought, like did they buy 1 hamburger or 2 hamburgers? And we have the price per unit. Then this is going to be the table, the model that we use for this whole next section. Okay, very, very simple. Are there other tables? Well, there's a table where I hold my measures, but no, there's no dimension tables or anything like that. Simple as simple can be. Okay, so with this simple data model, we'll come over here. If we have some measures, we can use those measures to create visuals. So we've got this very simple table right here. And let's say that I want to have a chart where I show total sales by shift. Well, I just click here on the visual, assuming I created it, right? So it's stack bar chart. In fact, I'll even be really good. This may bite me in the butt. The colors might not match. Let's start do this from scratch, right? So I want to create a visual with total sales broken down by shift. Well, if I already have a measure called total sales, I could just drag that over here, right? And now I just need to break it down by shift. Well, to break it down by shift, I go find the shift column that's in the sales table. And there we go, right? So that's how easy it is to create the visual once the measure is defined, right? That part's easy, right? So I've got total sales broken down by shift. In order to draw this visual, DAX produced a summary table that looked like this, and it was based on this physical table right there, right? And the instructions were the summary query that we were talking about. Great, that's fine, that's fabulous. But I have no idea, if I go click on this total sales measure, I have no idea at all, Brian, how this thing works, right? SumX, sales, what in the world is all of this stuff? Let's take a deeper look and see how we get these summary tables here on this visual, okay? So Millie's very excited about this. You could probably hear her in the background. So I'm actually going to minimize, I'll leave that maximized. I'm going to go grab my Excel file and hope that Teams doesn't crash. Oh, Teams may be crashing. You guys still with me?
Yeah, we see the Excel file.
You guys, oh, fabulous. Okay, because I can't. Okay, give me a second and I'll see if I can see it. I think it's no, that's you guys. Boy, Teams really doesn't like this scaling. Here, I'm just going to minimize this, and I'll just have to go without chat. Okay. If there's questions out there, I'm not going to be able to see them because Teams is having issues with my graphics card. But that's okay. You guys can just shout them out when I get to the question section. Okay. Mm-hmm. So here we have a whole lot of stuff, almost too much stuff, right? Now, if you'll remember, what we were building is this simple summary table here where we had total sales broken down by shift, right? And I'm going to show you how we got this $57 and the $43. I'm actually going to show you that down here. Before we get to that, though, what I want to show you guys is some of the tools that we're going to be dealing with, right? One of them is the physical table of the data model. This is the raw data that we're working with, right? So we've got all 1, 2, 3, 4, 5, 6, 7 sales transactions. We've got the unit, the price for each one, and we now have the shift, the type, and the dish. I already showed you that. Okay, that's not that interesting. What we also have down here is something called the filter context. If you've been working with DAX at all, you've almost certainly heard this term before, filter context. This is quite simple. This is just a collection of all the filters that are active at any given moment. And right now, it is completely empty. We'll come back to this in a second. We'll come back to this in a second when it becomes important, right? So we've got this empty filter context. And over here, we have what I call derivations, right? Derivations are the temp tables that can be produced at any given moment based on what's in the filter context. What do I mean by that? Well, if I were to ask in my code for the sales table, you would get a temp table that looks like this. Now, you look at this and you say, all right, this looks like that, but the formatting is a little bit different. Well, this is a permanent table. This is a temporary table. Yeah, that part's different. But here's the big difference, right? If I change what filters are in place, what I'm going to get back in this temp table is different. What do I mean by changing what filters are in place? Well, I have this handy little slicer, is technically what this is over here, and I'm going to change what filters are in the filter context so you can see what happens to the derivations, right? So I'm going to add a filter for lunch, right? Now, in your code, you're going to have to write code, but I'm just going to press a button and use the magic of a button to do it. So I click on
One
lunch.
moment, Brian.
Yes.
The screen seems to be frozen, or at least on my side. Is anyone else experiencing this?
Is it still frozen? I wasn't doing
the same. It's the same. It's frozen for everyone.
Okay, give me a second. Technical difficulties. Let's try and.
You're going so fast that I cannot even stop you.
That's a common occurrence for me. So let's see. Let's see what happens if I try and just reshare it. Maybe that'll be sufficient. So it's probably going to pop up. Let me know if it pops up first.
Yeah.
Okay, so now I'm going to kind of move my mouse around. Can you see me moving my mouse around?
Yes, it's visible. Much better. I think Brian's Teams just crashed.
You cannot win for losing, can you? I'm telling you,
Yeah.
It's crazy. It's crazy.
Well, it's Teams.
It's Teams. Yeah, I love, he's great, isn't he? He just I love his arms are going every which way.
Yeah.
Love him. He is amazing.
Just a reminder for everybody who's in the meeting, for everyone who joined late, we've started a great partnership with Enterprise DNA this month, and we're having, they are sponsoring Romania Power BI user group with 3 annual membership and 3 annual Analyst Hub licenses. There is a form that needs to be filled up, and if you want to go in the raffle, for now we have 12 answers to that form and 10 participants in the raffle. I will put again the link, and Brian is back. Good to have you back, but you're on mute. You are on mute. Let me see if I can unmute you.
How about now?
Now it's much better.
There we go. Okay. So we're going to roll the dice a second. I'm going to try and share my screen again. I'm actually going to close the PBIX file and see if that doesn't make this work a little better. Assuming I can actually even do that. Okay, so I'm going to go to Task Manager, and I'm going to kill it there. Oh, man, Teams is just making my life great today. Let's see. So we want Power BI Desktop. We're just going to go ahead and run that task. Okay. All right, so that part's a little sad, but if I could do the Excel part, I'll be happy. So we're going to give this a shot.
I passed the storm, so this should work too.
Good. Yeah, we've got 2 storms going on. Can you see my screen?
Yes.
Okay,
and the mouse moving.
And the mouse moving.
Slicing, yeah.
Great. So if I click on stuff, great. Okay. It's helpful if you can actually see things. I'm going to leave everything minimized as much as I can to create reduce the likelihood of another crash. So again, if there are questions, you can just shout them at me. I'm pretty good at that. Okay. Fabulous. So what happens if we remember, we were talking about our derivations over here. And so if we ask in our code for the sales table, we're going to get just the visible rows of sales. And by visible, we mean visible based on what filters are in the filter context. So I'm going to add a filter for lunch. And I'm just going to add it by clicking on this button. So when I click on lunch, right, we're going to add a filter to the filter context. Now that filter is for shift equals lunch. Now when I add that filter for shift equals lunch, suddenly that same derivation, asking for sales doesn't give me all 7 rows, but just the 4 rows. Well, which 4 rows? Well, the lunch ones, right? That's what we're looking at right now, right? If I click on dinner, right, I could change what filters in the filter context. Now there's a filter for shift equals dinner, and that same exact derivation, asking for the rows of sales, gives me just the dinner rows, right? If I click on, oh, I don't know, pasta, right? We could change the filter so the filter context has a filter for dish equals pasta in there. Now we're just looking at the pasta rows, right? Now notice here in the filter context, in the land of DAX, all filters are tables. So when I add a filter for lunch, I'm going to kind of sort of move over here by clicking on lunch. Now there's a filter in the filter context for shift equals lunch. That filter is a table. Tables are filters in DAX, right? And so if I click on maybe lunch and dine in, right? Now the filter context has 2 filters in it, one for shift equals lunch and one for type equals dine in. And with those filters in place, the visibility changes. So if I were to ask for the sales table in this context, what I get, the temp table that is produced, is just the visible rows, which if I'm looking at lunch and dine in is just that 1 row right there, which is why we get 1 row from that derivation. Okay, now let me set the filters back to empty. The most common derivation we're going to work with is this one right here, where we ask for just the name of the table, sales. But there's a couple other derivations that are important, right? In particular, this values derivation. What values does is it goes and gets all the distinct values that are visible in a particular column. So if I do values shift, put that right there. If I do value shift, right? Well, if we think about what's visible in the shift column, right? Well, we have lunch and dinner, which is why we get those 2 values right there. Now, if I click on lunch and add a filter for lunch, there's now a filter for lunch in the filter context. Well, what are the distinct values that are visible? Well, even though in the source table, we had both lunch and dinner rows, with this filter in place, we could just see lunch rows, which is why we just get lunch right there. Similarly, if I clear the filters, and I ask the question, just go show me all the distinct values in the dish column. Well, we've got pasta, burger, and we also have salad, right? But they only bought 1 salad all day, and that was at dinner. So if I were to click on lunch, right, now we only see pasta and burger because those are the only 2 dishes that people bought during lunch, right? But if I click on dinner, we can see pasta, burger, and salad because people bought all 3. Now, these 2 derivations, when you ask for a table by name and when you ask for all the visible values of a column, those are what we call respectful derivations. And by respectful, I mean they respect what filters are in the filter context. So if I add filters to the filter context, these guys change over here. See, you can watch them change, right? Now, by contrast, these ones over here, these are also derivations. They're also producing temp tables, but these are non-respectful derivations. And by that, I don't mean they're behind the gym smoking cigarettes. They're not that kind of disrespectful. What I mean is they don't respect the filters in the filter context. So when I add a filter for lunch, right, if I just ask for the sales table, that derivation will produce this temp table right here. If I use this derivation where I use the all function and point it at the sales table, I don't get just the visible rows. I actually get all the rows, all 7 of them, because that's what I'm asking for. I want to get a temp table that has all the rows in sales, ignoring the filters. Or similarly, right, if lunch is selected, no one bought any salads for lunch. If I ask for the values of the dish column, right, well, I get pasta and burger because nobody bought a salad. If I ask for all of sales dish, it says, well, what are all the values in the dish column, ignoring whatever filters are in place. So even though nobody bought a salad for lunch, this version has pasta, burger, and salad because it ignores what filters are in place. Okay, so those are our derivations, and they respect the filters in the filter context. In the filter context, all the filters are just tables. Okay, so let's actually watch some of this thing working a little bit. So I'm going to clear the filter context out again. Remember, we're trying to figure out how we get this total sales summary table, right? Well, the summary query that we're going to work through is an even more simplified version of what we saw before, but I think it's going to help you understand the concepts. So in order to get this summary table where we have total sales broken down by shift, we're going to have this summary query right here, right? So what are we going to do? Well, evaluate just means go run this stuff, right? So go run this stuff. What stuff? This right here. So what we're going to do is we're going to get a temp table with all the distinct values of shift, and then we're going to add a column to it. The name of the column is going to be total sales, And to populate the actual numbers in that column, we're going to run the total sales measure for each and every row, right? So here where it says value sales shift, that's going to produce a temp table that looks like that, right? Notice value sales shift, same as that right there, right? So we get lunch and dinner. It produces that temp table. That temp table gets sent to the add columns iterator, which is going to add a column to it. The name of the column is going to be total sales right there, right? And how do we actually get the numbers in that column? Well, we're going to go run total sales, that measure, for both that row and that row. When we run it for this row, we get 57 bucks. When we run it for this row, we get 43 bucks, okay? When we've got 57 and 43, well, the add columns function returns this whole temp table with a column added to it. And then we say, all right, that's the finished version of this. So this gets sent to Power BI in a format that looks like this, and Power BI can then draw it as a visual. Okay, so let's talk through how we get that 57 bucks though. Let's talk through how we get the $57, which is to say the total sales for lunch. Well, to do it, we're going to run the total sales measure in that row right there. So we're going to kind of imagine this right here, right? Go run this total sales measure in that row for lunch. Well, the total sales measure includes this code right here, right? But before we even look at the formula in the measure, measures are smart. They're what we call a revisor. And by that, I mean, they're smart enough to know that to get the right answer, they have to go and add filters for the current row, right? So if the total sales measure is going to produce the right answer, it has to add a filter for lunch. So before total sales runs any of this formula stuff down here, it's going to add a filter for lunch right there, okay? So we add a filter for lunch. We go from this, where there's no filters in place, to this, where there's a filter for lunch in place, which allows these derivations over here. All the lunch rows, and all the lunch dishes, and all the lunch shifts, right? Okay, so the measure, total sales, adds that filter for shift equals lunch. Now it can run the formula. Now what's in the formula, right? Well, it's a derivation inside of an iterator. So we've talked a fair amount about derivations. And the derivation I'm talking about is right there on line 3. Go get all the visible rows of sales. So we're going to go get all the visible rows of sales and then process that temp table with this iterator. Let's just focus on getting the rows first. So go get all the visible rows of sales. Well, because we have a filter for lunch equals, for shift equals lunch, it's these rows right here. So I'm going to go select these. Control C to copy. Come down here. I'm going to Control V to paste. Okay. So line 3 produces a temp table that looks like this, right? Just all of the lunch rows. Okay, good. So now we want to process it. So we've got that temp table. We pass it into the SumX iterator. So iterators always process tables the same way. They add a column to it. I call it the expression column. It's a column based on this expression right here in argument 2, or this little formula. And then we sum up the results. Okay, so I'm going to come over here. I'm going to type in EXP. This is the name of the new column that we're going to add, right? What is the formula for this new column? For every single row, multiply that row's units times that row's price. Okay, so just like I'm in Excel, I'm going to do equals. I'm going to take the units, and I'm going to multiply it by the price. I go ahead, hit enter, and I just Control C, and I Control V that formula all the way down. So on this row, units times price is 14, 2 times 7. On this row, units times price is 9, 1 times 9. On this row, it's 1 times 7 is 7, and on this row, 3 times 9 is 27, right? So we run this little formula right here, this sort of expression column formula, for each and every row. Now, that's all nice and good. This corresponds to the sales for each row in this temp table, but we want to sum them up. Well, thankfully, we're using the SumX iterator. So SumX, after adding this column, is going to sum up the results. So I'm going to come down here. I'm going to do equals. I do equals sum. And that's it. And I get 57 bucks. And that 57, by the way, is that 57 up here. That's how we got the $57. Okay, let me walk through another example, because seeing this over and over again, I think really helps. Okay, so we just did the $57 right there. In fact, I'm not even going to type in 57 right there. Now let's talk about how we got the $43. Okay, so I'm going to set the filters back. Let's talk about those $43. And I'm even leave this one up here so you can kind of see them both. Okay, so now we're going to run the total sales measure in this row. Okay. Now up here, the total sales measure said, okay, before I can run my formula, I have to add a filter for lunch. Down here, the same measure, total sales, is going to say, before I can run this formula, in order to get the right answer, I have to add a filter for dinner. So the measure is going to add a filter for dinner. So let's add that filter for dinner. Boom, there we go. So now we've got a filter for shift equals dinner in place. And now if we were to ask for the sales transactions, all the rows in sales, we would just get the dinner rows, which, by the way, is what we're about to do. Okay, so now that we've got the filters in place, the measure says I've added the filter for the current row. I can now go ahead and run my formula. Well, what's in the formula? It's going to be a derivation inside an iterator. The derivation is going to get a temp table, specifically this temp table right here. And the iterator is going to process it. It's going to get the sales for each row and then add them all up. So let's start with the derivation part. Go get all the visible rows of sales. Well, with this filter in place, dinner, it looks like this. I'm going to Control C and Control V. Okay, good. So line 3 right there produced that temp table. Notice up on this version up here, that exact same line, line 3 produced a different temp table. Up here, it got all the rows for lunch. Down here, it got all the rows for dinner. That's because the measure added the filter for the current row before it ran this stuff. Up here, it added the filter for lunch, so we get the lunch rows. Down here, the measure adds that filter for dinner, so we're just getting the dinner rows. Okay, so now we've got that temp table with all the visible rows in sales. We're going to add an expression column to it, right? A column that we're going to sum up, and it's going to have this definition right here. For every single row, multiply the units times the price. So I'm going to come over here. I'm going to type in EXP. The column doesn't really have a name. I like to call it the expression column because it's based on that expression or that formula. Okay, which formula? This one right here. For each and every row, multiply the units times the price. Okay, there's the units. Multiply those by the price. I hit enter. I do Control C, and I do Control V to copy and paste. Okay, now that's all well and good. Now I've got sales for each row, but I need to add all those up in order to get the right answer. Well, luckily, we're using the SumX iterator, right? The SumX iterator adds this column and then sums up the results. So we just added the column. Let's go ahead and sum them up. Equals sum. I get the $43, which is, by the way, the $43 we were looking for. So I can go ahead and type in 43 right there. There we go. Okay, so we just walked through our first example. I'm going to pause real quick and see if there's any questions. I'm even going to tempt fate by trying to open up the Teams chat window. Any questions out there so far?
There was one from Jessica. So anytime I use calculate, I am generating a disrespectful derivation table.
So anytime you use calculate, you are going to change what filters are in place. So like in my example here, I've got this handy like slicer checkboxy thing where I could change the filters by just clicking on stuff, right? In real life, if you want to change the filters, you have to use a revisor. There's two revisors that we're going to care about. One of them is measures. If you'll notice here, the measure added the filter for lunch, and down here, the measure added the filter for dinner. The other revisor is calculate. So calculate will add or remove filters from the filter context, which will then affect your derivations. So let's say that I want to look at, I don't know, pasta sales or something like that. I can use calculate to add a filter for pasta, something like that, or even we had dinner before, right? So we're going to use calculate to add a filter for pasta. So let's go get dinner and pasta. Boom, I can use calculate to add that filter. Once I've got the filter in there, then I will go derive some temp table, which will be affected by that filter that I added. So the revisor changes what filters are in place. The derivation actually gets a table based on those filters. Let me know if that helps, or if you have another question. Any other questions out there?
Yeah, there was an additional one
Sure.
about the variables. How long temp table exists?
Oh, good. So a temp table will exist between at query time is the technical answer for it, right? So we submit our summary query to the DAX engine. In order to produce the summary table, it will produce all of these temp tables. And then as soon as the summary table is complete, right, returned, they all get thrown away, wiped from memory. Now, there is stuff that gets cached. You can go retrieve it again faster later on, but the temp tables are technically gone. Temp tables are technically gone. Any other questions?
And there was another one. I guess we can see a temp table by stashing it in a variable.
It's actually pretty hard to, you could definitely store a temp table in a variable. That's something I highly recommend. It's a really good way to work. To see it is very tricky, which is one of the reasons I built all this stuff in Excel, because otherwise they're almost impossible to see. I've got some tricks to use the concatenate X function to kind of show them to you, but the reality is you can't see temp tables. You can only imagine them in your head. So things like this, where I show them to you in Excel, or even some of the stuff in my Elements of Daxers, is there so that you could practice seeing the temp tables on a screen so that you can be better at looking at your code and imagining what they look like. But you can't actually see them, which is one of the reasons they're really hard to work with. Any other questions out there?
And could you please explain a bit about iterators, like what does they do?
Fabulous. Very good question. Okay. So we got a temp table right here. So line 3 produced this temp table right here, which is effective. It has the information that we want, right? I'm going to Control Z and backtrack just a little bit. There we go. Okay. So I'm going to hit escape. So we got the temp table we wanted, right? We used this derivation on line 3 to go get all the visible rows of sales. We got those right there as a temp table. Now, I know that my answer is in this temp table. I know as a human being, a smart human being, if I could just, for every single row, multiply the unit time the price, multiply the unit time the price, multiply the unit time the price, get a number there, and there, and then add those 3 numbers up, that would be my total sales. That's the number that I actually want to produce. I can use an iterator to do that, right? Iterators process temp tables. That's the verb that I use. What I mean by that is they're all going to add a temporary column to a temp table. I call it the expression column. You can call it whatever you want to, right? So when I type in EXP here, this is the column that the iterator is going to add. So SumX is going to take that temp table as an argument. So this right here is argument 1 to SumX, the table to add a column to. Argument 2 is the definition of that column, right? So we give SumX this temp table right here, and it's going to add a column with this definition, right? And if you use a different iterator, it's still going to add a column, right? So if I were to use AverageX, I would still have to provide it the definition of the column that I want to add. In fact, maybe I'll do that example next, right? So here with SumX, right, argument 2 is the column that we're going to add. So I get units times price equals units times price. Copy and paste that all the way down, right? So the iterator added that column, and the iterator, the SumX iterator, also summed up the results. It does those 2 things. It adds the column, and then it performs some task on it, usually an aggregation. SumX will add the values up like this. Right? If this wasn't SumX, it was AverageX, it would average those numbers, right? If it were MinX, it would get the smallest of those numbers. If it were MaxX, it would get the biggest of those numbers. If it were MedianX, it would get the median of those numbers. Any of those X iterator functions, they're always going to add this temporary column to the table and then do something with the result. What they do with the result is usually the name of the iterator. SumX sums them up, AverageX averages it, MinX takes the min, MaxX takes the max, MedianX takes the median, right? All of those iterators do the same thing. Okay, so let me know if that helps. But I want to get through one more example because I think it'll sort of maybe help solidify some of these concepts right here. Right?
Yes, it helped.
Fabulous, fabulous, fabulous. Okay, so I'm going to minimize this chat window again just so I don't get crashed. And we're going to do, in fact, why don't we do average units? We'll skip one just so we can skip to see a different iterator. Right? Okay, so now the summary table that we want to produce is average units by type, dine-in or to-go, right? And we're going to use a formula that looks like this. The definition for our measure, average units, is average X sales units. Okay, so we're going to use a different iterator. It's still going to add a column to a temp table. The temp table is produced by this right here, and it's going to average the results. Okay, so let's walk through this. Okay. To produce a summary table with average units by type, we're going to have a summary query that maybe looks something like this, right? Evaluate, go do some stuff, right? We're going to add a column to a table, right? Well, the table that we're going to add a column to is based on this right here. Go get all the visible values in the type column. Well, if we look at the data right here with no filters are in place, there's to go and dine in. So it produces a table that maybe looks like this with dine in and to go, right? So this right here corresponds to that. That produces that temp table, all the distinct values of the type column, which we then pass into the add columns iterator, which is going to say, I'm going to add a column to this temp table. The name of that column is going to be average units. Average units. The formula that I'm going to run for each and every cell of that new column is this, the average units measure. So I'm going to run the average units measure there, and I'm going to run the average units measure there, right? So if I run it here on the first cell, I get 1.33. That's the average units for dine-in. If I run it on this cell right here, that's 2. So the average units for to-go is 2, right? So once I've got those numbers in place, well, then I've got my new column that has been added. And this is the result that we want. So since this is sort of the top level version of this, this is what you get after the add columns is done adding that column. There's the column right there. This is actually going to get converted to a summary table and sent back to Power BI, which Power BI can then draw as a visual. So let's walk through how we get this 1.33 right there. Okay. So we're going to run the average units measure in this row right here, the dine-in row. Right? Because that's what we're trying to figure out. We'll figure out the green one in a second, right? So we're going to get average units for dine-in. Now, measures are smart. They're revisers. They're going to revise the filters, change the filters, add a filter, right? Before they run their formula. So this measure right here, before it runs any of this stuff, before it does anything, the very first thing it does is look to see if there's any values in the current row. There is, type equals dine-in, and then it's going to add it as a filter. Okay, so the measure is going to add that filter. So I'm going to go click on dine-in just so we can see that graphically. Good. The measure added a filter for type equals dine-in. Now our possible derivations has changed because we're just looking at the dine-in rows. Okay, so now with that new filter in place, the average units measure can start evaluating, right? And so what's it going to do? Well, we're going to use this average X iterator. Average X is an iterator. It's going to take a temp table, add a column to it, and average the results, okay? The temp table that it's going to add a column to is this here, line 3. It's this derivation. So let's go see what that table looks like. If we go ask for all the visible rows of sales, we don't get all 7 rows. We just get these 1, 2, 3 rows, the ones that are the dine-in rows. So line 3 produces a temp table that looks like that. There we go. We've got 1, 2, 3 dine-in rows. So that little bit of code right there where we ask for sales produces this temp table. That temp table is what we hand off to the average X function. We say, dear Mr. or Mrs. Average X, here's a temp table. I would like you to add a column to it that looks like this. And then because you're average X, naturally, you're going to average the results. If I wanted to sum those results up, I shouldn't be talking to average X. I should be talking to SumX. If I wanted to min those results up, I should be talking to minX. But we want to average them, so we're going to use average X. Okay, so we take this temp table, we hand it to average X. Average X says, okay, what's the column that you want to add to it? Oh, it's right there. For every single row, get the units. Oh, okay, I can do that. That's even easier. So here's that expression column. It's based on that expression or formula right there. The column doesn't really have a name. It's sort of a temporary column, but I like calling it the expression column. I like that big X right there. Okay, so for every single row, go get the units. Well, for that row, go get the units, right? Then I'm going to Control C and Control V. So for this row, we get 1 because that's the units for that row. For this row, we get 1 because that's the unit for that row. And for this row, we get 2 because that's the units for that row, okay? So average X added this column right here. Get the units for each row. I get 1, 1, and 2. And now we're going to average the results because this is the average X function. If we wanted to sum them up, we should have used the SumX function. So I'm going to do average. And I hit enter and I get 1.33, which, by the way, is the answer we were looking for. So this returns 1.33. Good. Okay. Good. I'm going to reset the filters. And let's do the bottom one. So we just got 1.33. That's the average units for dine-in. Let's go get the average units for to-go. Okay. So up here, we ran the average units measure in the dine-in row. And now we're going to run the average units measure in the to-go row. And since measures are smart, they're revisers, before they do anything else, they know that in order to get the right answer, they have to kind of look to the left and say, are there any values of the current row that we need to add as filters, right? So it says, oh, yeah, in order to get the right answer, I need to take this value of the current row, type equals to go, and add it as a filter before I run any of this stuff. So the measure goes ahead and adds a filter for to go. So I'll come up here and simulate that. Good. Okay, so the measure, the average units measure, before it ran its formula, added that filter for to go. So now what are we going to do? Well, we've added the filter. We can go ahead and run the formula. And just like before, we're going to use the average X iterator, which is going to take a temp table, add a column to it, and then average the results. Okay. The table that it's going to add a column to is argument 1, all the visible rows of sales as a temp table. Okay, so what's that? Well, that's this right up here. Right. So I'm going to go ahead and scoop this up. Control C to copy. Come down here. Control V to paste. Okay. So all the visible rows of sales is a temp table. Hey, there it is. Now notice. Up here, when we were doing it in the dine-in row, we asked for the same thing, all the visible rows of sales. But up here, we had a filter for dine-in, so we just got the dine-in rows. Down here, the measure added a filter for to-go, so we're just getting the to-go rows, right? Okay, good. So now we've gotten all the visible rows of sales, which, by the way, are the to-go rows because the measure added that filter. We're going to take that and pass it into average X. Average X knows how to process temp tables. It's going to take this temp table right here, and it's going to add a column to it with this definition. For every single row, get the units. I'm going to come over here. I'm going to type in EXP. The column doesn't really have a name. I like to call it the expression columns. It's based on an expression or a formula. Okay, so for each and every row, just go get the units. That's easy. Control C. Control V. Okay, so for that row, I get 2 because there's 1 unit. For that row, I get 1 because there's 1 unit. For that row, I get 3 because there's 3 units. And for this row, I get 2 because there's 2 units, right? Not rocket science. Okay, so average X took this temp table right there and added a column to it with this definition where I get the units for each row. And now we're going to average it because it's the average X function. So I click right here. I type in equals average. I average those. And that is how I get 2, which, by the way, is the answer we were looking for. 2 right there. Not 200, but 2. Okay. And that is how it gets the answer. Okay. So I've shown you 2 examples. I'm going to pause real quick. Any questions? And if the concept of iterators is still fuzzy, please call that out as a question. What are you guys thinking about? And we may have time for one more example, depending on how folks are doing. I know it's getting late out there.
No additional question on iterators, and it was very well explained.
Fabulous, fabulous, fabulous. Okay, so shall we do one more example? One more example? Why don't we do, I'm going to do lunch sales real quick, because I want to show you guys how calculate works, because we've kind of been avoiding the giant dragon in the room, the scary thing, which is calculate. And I think what you'll learn is calculate it's still tricky, but it's not that bad, okay? So here in this example, we want to calculate a summary table that has lunch sales by type, dine-in or to-go, right? Now, if you notice, the name of the measure is lunch sales, so it better darn well just be looking at sales for lunch. Okay, so how are we going to build this summary table? Well, it's going to be a summary query just like before. We're going to go add a column to a temp table, so we're going to get all the visible values of the type column, dine-in to go, and we're going to add a column to it. The name of that column is going to be lunch sales, right there. And how are we going to get the numbers for this new column? Well, for each row, we're going to run the lunch sales measure. We're going to run it there, and we're going to run it there, okay? So when we run it for the top row, we get $7. When we run it for the bottom row, we get $50, okay? So now that we've got 7 and 50, we've got all the values for our new column. Add column says, okay, this is going to be the thing that I produce, right? And since there's nothing else above it, this right here where we get lunch sales, 7 and 50 by dine-in to go, that becomes our summary table. That's what gets sent back to Power BI to get drawn as a bar chart or a column chart or whatever, okay? So how do we get the $7 and the $50? Well, let's scroll down and find out, okay? So here we're going to run the lunch sales measure in the dine-in row. Now, if you'll remember, measures are smart. They're revisers. They're smart enough to know that before they run their formula, they have to go add any filters for the current row. You may have heard this before referred to as context transition, or maybe you've heard me call it current row filtering. Whatever you want to call it, the idea is the same. Go take any values of the current row and add them as filters. Otherwise, the number's going to be wrong, right? So if we're trying to get lunch sales in the dine-in row, we have to add a filter for dine-in. The measure says, okay, I'm going to add that filter for dine-in. So I click on dine-in. The measure, before it runs anything in the formula, adds a filter for dine-in. So now we're just looking at dine-in stuff. Okay, so now we've got our lunch sales measure. We've added the filter for dine-in. We can start running the formula. And the very first thing that we encounter in the formula is this calculate function. Now, calculate is a reviser, just like a measure. Its job is to run a subformula with new filters in place, right? And by that, I mean, it's going to run this bit of code right here, but only after we've added a filter. Well, why? Because the name of this measure is lunch sales. Before we could go calculate the sales for lunch, we have to add a filter for lunch. We don't have one right now. Right now, we just have a filter for dine-in. So we're going to have to add a filter for lunch over here. Calculate says, I get it. Okay, we're going to go run this formula after we add a filter for lunch. Well, how are we going to get the filter for lunch? Well, that's this bit down here. Argument 2 of calculate is what filter would I like to add before I run this little subformula, okay? Now, to help us remember that this subformula or the sub expression is going to run after we add the filters, I'm actually going to freeze it here in Excel. So I'm going to select those cells, right click, and I'm going to add this sort of blue shade to it. Okay, brr, nice and cold. Okay, so this is what's going to run after we add a filter. Okay, so this down here is going to determine the filter that we add, which, by the way, is going to be a little 1 row, 1 column table with lunch in it. Let's see how we get it. Well, it's a derivation inside of an iterator. So the derivation is we're going to go get all the values of the shift column. And since we use this all function, that's one of our non-respectful derivations, it's going to ignore this filter for dine-in. So go get all the values of shift. All right, well, there's 2, lunch and dinner. So I'm going to go scoop those up. Control-C to copy. Come down here, Control-V to paste. So we get lunch and dinner. Okay, so now we're going to pass that into the filter iterator, which, like SumX or AverageX, is going to add a column to that temp table and do something with the result. The definition of the column it's going to add is for every row, see if that row's shift is equal to lunch. I'm going to come over here, I'm going to type in EXP, and I'm going to say, does that equal the text string lunch? I get a true there, and I get a false there. So what does filter do with these values? Well, SumX sums them up, AverageX takes the average. Filter is just going to keep the true rows, which means it's going to dump the false rows. So we're not going to keep this row right here. We are going to keep that row right there. So filter is going to take that temp table and just keep the true rows. So what's the true row? The one true row is lunch. So this bit of code right here spits out that temp table. That temp table gets handed off to calculate, since this is argument 2 of calculate, and says, hey, Mr. Calculate, Mr. or Mrs. Calculate, that sub-expression that you want to run, I want you to add this filter before you run it. Calculate says, you got it, boss, right? So we add a filter for lunch. So right now we're looking at dine-in. We want to look at lunch and dine-in. So we're going to add that filter. Boom. Now we took that temp table and added it to our filter context. A second ago, we were looking at dine-in. Now we're looking at dine-in and lunch. Now Calculate says, okay, good. We're done changing the filters. Go ahead, unfreeze this bit and run it. So I'm going to unfreeze this, throw it in the microwave for 30 seconds. There we go. Calculate, we can now run this bit right here. So go get all the visible rows of sales, add that column to it, sum up the results. Well, what are the visible rows of sales? Well, there's not very many right now. It's a little slim pickings at the moment, but we could get it anyways. Control V, there we go. There's all the visible rows of sales as a temp table. So there it is. We're going to take that and pass it into SumX, which is going to add an expression column to it with that definition and then sum up the results. Okay, let's add the column, EXP. For each and every row, multiply the units times the price. I get $7. And what do I do with the results? I sum them up because this is SumX equals sum. I get $7. And that, by the way, is how we get that $7 right there. Set this to $7. Let me do one more, and I'll do it kind of quick because I know we're sort of pressed for time, right? So let's go ahead and do the exact same thing, but we're going to do it for the to-go row. And I'll do it kind of quick, okay? Just so you can see calculate twice because it's such an important function. Okay, so the lunch sales measure, we're going to run it in the to-go row. Now, since measures are revisers and they're smart, before it runs the formula, it's going to add a filter for to-go. So let's go ahead and click on to-go. So the measure adds that filter for to-go before it runs its formula. Now that we've added the measure, the filter for to-go, we can go ahead and run this formula. Now, when we start running the formula, the very first thing we hit is the calculate function. The calculate function says, hey, wait a minute, dummy, you forgot to add a filter for lunch. This thing is supposed to be calculating lunch sales, and there's no filter for lunch in there. Right now, we can see both lunch and dinner. So what I need to do is I'm going to have you change the filters. Then we will run sort of a sub formula or a sub expression. So this bit right here, argument 1 of calculate, argument 1 of calculate is what we're going to run after we change the filters by adding a filter for lunch. So I'm going to freeze this, just so we can remember that argument 1 of calculate is the last thing that runs because it's the bit that runs with the new filters in place. Okay, so only run this after the new filters have been set up. What's the new filter we want to add? Well, that's argument 2 of calculate. Calculate says I want to run this with this filter. Let's go figure out what this filter is. It's going to be a temp table. Okay, go get all the values of the shift column. Well, that's up here, lunch and dinner. Control C, come down here and Control V, right? So we get lunch and dinner. There we go. So line 10 produced that temp table right there, but we want to process it with an iterator. So the iterator we're going to use is not SumX or average X or max X. It's the filter function, which is an iterator. It is also going to add an expression column to a temp table. There's the temp table. There's the definition of the column it's going to add for each and every row. For each and every row, check to see if that row's shift is equal to lunch. I get a true for the top one, and I get a false for the bottom one, right? Lunch equals lunch, dinner does not. And what does the filter iterator do? It's going to get rid of the false rows and keep the true rows. So it's not going to keep both rows. It's just going to keep that one lunch row. Okay, so lines 9 through 12 produce a temp table that looks like this. This is the filter that we want to add. Okay, keep in mind, this is argument 2 of calculate. This temp table gets handed off to calculate, which is, I need to go run this formula with a new filter in place. This is the new filter I want to add. So right now we're looking at type equals to go. We want to add a filter for lunch. So we're going to be looking at lunch to go. I'm going to click on lunch to go. Boom, we added that filter. Calculate added the filter. So now the calculator has added that filter. We can go ahead and unfreeze this sum expression and run it because the filters are now correct. The filters are now correct. I'm going to click on this. Unfreeze that. And now what do we do in here? Pretty simple. Go get all the visible rows of sales, add this column to it, sum up the results. Here's all the visible rows of sales. We go get that temp table. Boom, there we go. There's all the visible rows of sales. Notice it's just the lunch to go rows. We add a column to it with this definition for each and every row. For each and every row, I would like you to take that row's units and multiply it by that row's price. So units times price. I do that for each row. Copy and paste that down. So 2 times 7 is 14. 1 times 9 is 9. 3 times 9 is 27. And what do we do with this new column that was defined right there? Well, since this is the SumX iterator, it's going to sum it up, right? So I'm going to do equals sum. And I get $50, which, by the way, is the $50 that we were looking for. And that is how measures work inside of DAX, even using the big, scary calculate function. Okay, I know we're a little over on time. I really appreciate you guys joining. Any questions out there?
Yeah. Could you please explain one more time the difference between respectful and non-respectful derivations?
Good. Great question. Fabulous. Okay, so notice here we have a filter for lunch and to go in place. These derivations over here are going to respect those filters. Notice we don't see any dinner rows and we don't see any dine-in rows. We only see lunch and to go. Here where it says lunch, this is because it's respecting that filter for lunch. Here where we see pasta and burger, we're only getting the dish values for lunch and to go. So you see pasta and burger right there. By contrast, there were another set of derivations we could use, the non-respectful set of derivations. They do similar things, but they ignore whatever filters are in place, right? So here, if I were to ask for all sales, right, instead of just getting the lunch and to go rows, lunch to go, I get all the rows. I get lunch and dinner, to go, and dine in, right? And down here where I ask for all the distinct values of the dish column using the all function, because this is non-respectful, that's what the all function does. It says, I don't care that we're supposed to be looking at lunch and to go. I'm going to look at everything. I'm going to ignore what is in this orange box, and I'm going to see all the values. And if you look at all of the dishes, we've got pasta, burger, a bunch of duplicates, and then salad down there. So the non-respectful ones are when you want to temporarily ignore the filter context when you're creating your temp table. That is the main difference. If you want to have the filters in the filter context affect the temp table that you're getting, use a respectful derivation. If you want them to ignore the filters in the filter context when you get your temp table, use a non-respectful derivation. That is the difference. That's the difference.
Thank you. And the last one from Gunjan. Could you please show again the spider, the so-called spider in the presentation, and explain the high-level mix between measures, revisers, derivators, and iterators?
So I'm going to try. We're going to temp fate one more time, and I'm going to see if I can't get that. Oh boy, everything is just not working very well at the moment. That's okay. Give me a second, and we'll see if we can get that opened up.
No problem.
If I crash, you know what happened.
Yeah. We'll be here. We'll run the raffle meantime.
Oh, right on. Okay.
Crashes. Anyway, it was a great presentation. Loved it.
Thank you so much.
Even if I saw it before, I'm learning every time something new.
Oh, thank you so much. And DAX really is that way, right? You just have to see it over and over and over again to get it. Understanding something conceptually, it's nice. You just have to get exposed to it a whole bunch. That way you start to see the patterns. That's always my experience anyways. I'm glad that you're learning new stuff each time.
Yeah, every time.
Okay, so let's see.
And I also loved your Power Query videos.
What's that?
I also love your Power Query videos that you're posting.
Oh, thank you. Let's see. Oh, I'm going to remove those. I don't think there's anything important in there. Okay. So let's go look at the spider web. Okay. So there's three elements. There's derivations, iterators, and revisers. Derivations are the thing that create temp tables, right? They create temp tables based on the physical tables and whatever filters are in place, okay? So you basically always start with a derivation, right? So in the beginning, there was a temp table, right? We have to start by creating a temp table. Then we have some choices to what we do with it, right? If we're perfectly happy with the temp table as is, right, we could say, I'm going to take that temp table that I produce and I'm going to pass it to a reviser, right? So there's the temp table that was produced by the derivation. I could pass it to a reviser and say, hey, I would like you to add this as a filter, right? So maybe my derivation is go get all of the shifts. So maybe before I was looking at lunch, but I go get a derivation with lunch and dinner, and I take that temp table with lunch and dinner and I pass it to a reviser. And the reviser says, okay, I'm going to change the filters, because that's what revisers do. They change the filter. So it takes that temp table with lunch and dinner and creates a new filter context looking at not lunch anymore, but lunch and dinner, right? So it creates a new filter context looking at lunch and dinner. So now when I perform a derivation, it's going to do it with that new filter context in place. So revisers are in charge of changing what the filters are, which in turn changes what you get when you perform a derivation. So if I ask for all the visible rows of sales, if there's a filter for lunch in place, I get the lunch rows. If there's a filter for dinner in place, I get the dinner rows. If there's a filter for pasta and lunch in place, I get the lunch and pasta rows. So what I get from a derivation is completely dependent on what filters are in place. And if I want to change what filters are in place, I have to use a reviser. That is, by definition, that's how that works. I could use calculate, I could use a measure, I could use calculate table, but I use one of those three to change what filters are in place, which in turn allows me to get different sort of views of the tables in the physical tables. Just the lunch rows, or just the dinner rows, or just the pasta rows, okay? So in addition, right, I could also take that derivation and say, you know what, I don't like this temp table as it is. I want to process it, and I could pass it to an iterator, right? So iterators require temp tables, which is why you have to start with a derivation. You say, I'm going to take a temp table, I'm going to process it. So I'm going to add a column to this temp table based on some definition. For each row, multiply the quantity times the price. For each row, check to see if the dish is equal to pasta, right? And depending on which iterator you use, you will either produce a scalar, which is to say like a number. So if I use SumX, I'm going to add a column and then sum up the results. If I use AverageX, I'm going to add a column and then average the results. If I use MinX, I'm going to add a column and then take the minimum value of those results. If I use the filter iterator, though, I'm going to add that column and I'm just going to keep the true rows. So rather than producing a number like the average or the sum or the min or the max, I will actually produce another temp table, right? A temp table with just the rows where the column was true, right? So what do I do with that? Well, there's a couple things I could do. I could take the iterator and I could send that to the reviser and say, hey, you know what? I'm going to get a derivation that's got all the values of shift, both lunch and dinner, right? But I don't want to look at lunch and dinner. I just want to look at dinner. So I take that temp table that has lunch and dinner, and I pass it to the filter iterator, which says, just keep the dinner rows. It's going to spit out a temp table, which I can then pass to a reviser. And the reviser, what does it do? It just changes the filters in the filter context. So it takes that dinner temp table and adds that to the filter context. So now we're just looking at dinner. What's the point of doing that? Well, because I want to go derive some temp table just looking at dinner, which I could then pass to an iterator to sum up all the transactions in it, right? If I want to do something like that, okay? So there's another piece, though. There's another piece where when you are adding that column to the temp table, you can actually perform a more complex calculation inside of it. You can even do a derivation inside of it, right? So if you'll remember, let me scoot back here for a second. We scooch up just a smidge, right? When we're looking at like this row right here, we're going to go run this whole big formula in that row right there. And when we do, we're doing a whole bunch of stuff in there, but the iterator is creating the set of rows to process. So the iterator basically says, I want to run the measure here and I want to run it there. So when it runs it here, it runs it in that row. And when it runs it here, it runs it in that row. So the iterator basically says, here's a set of rows I want you to run a formula for, right? Here's the rows that I want to run that formula for. So because of that, it's the only thing in DAX that can create a set of rows that you run a formula for, which sounds more complicated than it is, right? If I'm going to add a column with this definition, I'm going to run this formula both there and there. And when I run it there, it happens in that row. And when it's there, it happens in that row. And when I say in that row, that's a fancy or a not fancy way of saying row context. Row context is just all the values of the current row. So I can run the same formula, lunch sales and lunch sales, in that row and in that row. And because of that, if you'll remember down here, when I ran it in that row and I added the current row's values, it added a filter for dinner. Down here, when I added it, it added a filter for to go because it adds the value of the current row. So the value of the current row is the row context. What is in the current row? Now, that notion of a current row, I can use a reviser such as a measure or calculate to say, you know what, that value of the current row to go, I want to actually add that as a filter. So if I scooch back here, right? For each and every row of the column that I'm adding, I can actually use a reviser and say either a measure like we saw in the example or calculate, and it will perform context transition, which is a very fancy sounding word. All it means is take the values of the current row and add them as filters. So back in the example, here we add to go as a filter. Up here we add dine as a filter. It performs context transition. Take the value of the current row, type equals dine in, and add it as a filter. Or I guess here's a better one. Take the value of type equals to go and add it as a filter, right? So the iterator created that idea of a current row, and then the reviser, the measure specifically, added as a filter, right? So that is what we say if you're running, if you use a reviser inside of the definition of your row by row expression, your formula for each row, the reviser, calculate, or a measure will take the values of the current row and add them as filters. Why would you want to do that? So you can perform a derivation, which is, by the way, if you remember, let's go back to an easier example, just total sales, right? The reason we got 57 and 43 here is because we got different derivations. Up here, when we asked for all the visible rows of sales, the measure had added a filter for lunch. So by converting the row context, lunch, to a filter context, up here, lunch, when I perform this derivation, I got these rows. Down here, I run the same formula, but because the measure took the current row value of dinner and added it as a filter, right? Let's add it as a filter. Now, when I perform this derivation for sales, I get the dinner rows. So the measure changing the filter like this, right? That's the reviser part, changing what filters are in place. Well, why would you want to change what filters are in place? Because in this version, you want to be just looking at the lunch stuff. And down here, you just want to be looking at the dinner stuff. Okay, so that is, you asked for a short answer. I think that's my best approximation of a short answer to that. That is all of the very basics, ins and outs of the spider web, right? Of the sort of inherent relationship between these three elements.
We see it much differently now because we saw the examples. So it's very good that we had it in the end as an overview.
Yeah,
it's very insightful.
Yeah, it's tricky, but it's not that tricky, right? And if you go back and forth between the examples and the diagram, you start to pick it up and say, "Oh, I get it. It really is quite simple. It really is quite simple." Okay.
There are no more questions. No more questions. Thank you very much. It was great. It was a really, really great session.
And fabulous.
Thank you for your time.
I'm really glad you guys enjoyed it. Hey, did we post the link to the Elements of DAX series? I just want to make sure that gets out there. It's good follow-up.
Yes, it's in the chat, and I will send it with the recording and in the video description of this session also.
Okay, fabulous. I know there were some pickups, but I'm so glad they made it through.
Yeah, it was great, and you have a lot of thank yous and great explanations in the chat. Thank you very much. We still have 5 more minutes for the raffle. So can I please share my screen?
Sure, I'm going to kill this, and I'll even kill my video.
Okay. I think it's you should see my screen now.
I can see it.
Okay, and now it should be a Power BI file. Is it visible?
Yep.
Yeah, I don't see the chat anymore. This is why I'm a bit surprised. Let me move this one over here. So basically what I did with the form, I build a flow, taking the data from the form to a SharePoint list, sending an email to the ones, actually 2 different emails for the ones that want to participate in the raffle, and another one for the other ones, for the ones that don't want to be participants. I'm storing everything in a SharePoint list, and then I built a Power BI report based on that SharePoint list. And inside the Power BI, I've built Power Apps with a flow inside, with a flow triggered from Power Apps. And that second flow, it's actually randomizing the numbers for the ones that opted in for the raffle. And the best thing to test it is just to refresh the Power BI file. We have the last refresh here. We should have a refresh now. So we have 18 answers to the form, 16 participants in the raffle. And if I'm pressing this button, choosing the random winner, these dots that you see, exactly what I was not expecting. Let me see if it worked a little bit. Probably didn't. Raffle entry, yes. 1, no one. So it's not working. I think this will be done probably at the beginning of the next meetup, because I don't want to keep everyone. I'm having the registrations here. I will try again. And if it's not working, no response. I cannot say bad words during the meeting, right?
I won't tell, but you should probably stop the recording.
Yeah, I will stop recording and curse afterwards. So sorry that the second flow didn't work. I don't know what happened. As usual in the demo, something is happening. I have the list with everybody, and we will do the full at the start of the next meeting for this one, and at the end of next one, we'll do it for that one. So thank you everybody for joining. Thanks again, Brian, for sharing your knowledge. It was really great. And hope to see you next time.
Thanks very much. This has been a ton of fun. I really appreciate it.